I am Kat McIvor. So this talk is going to be having a look at some of the very basic kind of introduction to Docker bits and pieces, because it's a technology that's been around for a while. Lots of people know bits and pieces about it, but I always found that whenever you're talking about it, there's this assumption that you already knew. And if you didn't already know, you're not one of the cool kids, and therefore we're not talking to you anymore. So this was a kind of aim, and I've done it at another conference before, in order to let people become one of the cool kids. And I don't know if any of you were in the 7 deadly deployment sins talk just now, but Docker is cool, damn it. I like it. So if you've done any Docker before, apologies, this might be a little bit dull, because we're going to go in from the ground level of building some stuff and then playing with it. But I do have some extra bits on top around templating for Docker files and having a look at how you can test it as well. So hopefully we'll get time to get onto those. So feel free to harass me on Twitter. I don't get anywhere near enough harassment, I feel. I should get a bit more. All be good. So my plan for this talk, and I will apologise now for the amount of sarcasm and poor jokes I put in that subtitle. They gave me subtitles. This is amazing. The plan is to have a look at what Docker is, kind of what's the point of it, why do we bother, why do we care? Starting, stopping, interacting with containers, so sort of very much what these things are, how we can be horrible to them, how we can build our own containers, because it's okay saying, well, I'll go get someone else's Jenkins container, but that container doesn't have all of my security settings in, so I want to be able to build my own version of that. There will be a kind of mini rant on the subject of tagging. Some of you may have already heard it. Tagging in Docker is an interesting minefield of horror. And then we'll have a bit of a look at security in containers, because I know this is kind of an introductory thing, but security should be one of those things you do from the beginning. It shouldn't just be, oh, we'll worry about that later. Because the amount of things that can go wrong, well, I'm pretty sure most people have seen what happened to the NHS. So let's just think a bit about the security from the ground up. So I would love if you guys, across this talk, shout stuff out, tell me to type things, tell me where I'm going wrong. I am going to spend probably most of it sat on the terminal rather than slides, because slides are boring. So if you want to know what a thing does, we'll try it out. If I don't know what it does, I'll Google it. I mean, Google has all the answers, and we'll just hop on Stack Overflow. Someone will be more intelligent, right? So, step 1, what are containers? Go on. What's a container? I went to Google. It's brilliant. Anyone? Container, what's it mean to you?
I think shipping container in mine.
Yeah. That's pretty much what this second one is, so the large metal box idea. So before we had a lot of this automated delivery, a lot of these container ideas, certainly working in a kind of operations side of things. I don't think it's unfair to say that everything was on fire all the time. That there was a fire, and occasionally developers would give you some more fire to put into your existing fire, and you just hope it wouldn't all collapse. So the idea with containers, and they're not new, Docker is not the first person to have ever done this before, but the idea with them is to get everything that an application needs in one place so you can deploy it all in one go. And I mean, who has an Android phone, iPhone? I'm going to assume most people. Right, so every single application on that runs in a container. Who's been using Java? I mean, everything with that is based on containers. You put everything into a single jar file. Now they're self-executing as well. Spring Boot's just taken it and gone, yeah, we'll have it nice and easy. Containers are not new. The Linux people have been very grumpy because it's been around for about 20 years. It just wasn't cool. I think it was called LXC. Doesn't that sound kind of fun? No. Docker sounds fun. We've got a whale. So yeah. If you think of containers, think of a box that you shove a load of stuff in, you can close the lid, and it doesn't matter what's inside compared to what's outside. It doesn't matter how you're interacting with it. You've always got the same way of take this container off a boat, put it onto a train. Same idea. No matter if it's tractors inside, chocolate cake, always the same process of loading, unloading, same process for opening it, same process for putting stuff inside it. Okay, so what's inside might change, and you might have a bit of a weight distribution issue on your ship, but there's only so far I can take a metaphor. So the next question I usually get is, but virtual machines. So containers and virtual machines are not quite the same thing. A virtual machine, the idea is you have a self-contained system in which you put everything your application needs to run and it stays as a single unit. But you also get hardware emulation. So you get your memory, you get your CPU emulation, you get absolutely everything you need built into that one thing, even if you don't want it. And I know certainly my Android development stuff about 4 or 5 years ago, that virtual machine was horrific because of the amount of emulation it had to do. We're talking 10 minutes to start up and don't you dare close that thing today. Whereas a container, we've still got a similar idea. So we still, at the bottom, no matter what someone says about how serverless we are going, we've got a bare metal thing running our stuff somewhere. I'm sorry, but serverless is still running on a server, it's just not yours. Somewhere there's a server. On top of that, you've got a host operating system. Sometimes this can be squished a bit. I know VMware have done some really interesting stuff with theirs, just being able to chuck virtual machines straight on the bare metal. Then you've got either your kind of hypervisor level or the Docker engine. Now, the difference you get with these is Docker will try and share as much information as you can. So if you've got 5 Java applications, why do you need 5 copies of Ubuntu, 5 copies of the JVM? They're just files. And I know operating systems seem a bit like magic to some people, but they're just files. They're not special. So you can have 1 copy of this that everything runs on, and it's only as you get further up that you start separating things out. So you go, well, I'm going to have a different set of libraries for application A versus B. This one's going to run on Node. So we're going to have a separation there. So it's whenever something changes, you get this new layer spawning. And you get this big, long chain effect going through it all, where you can actually have a look at what you've got and see how much it can share. And Docker will do all this for you automatically. Some people don't like it. So what you tend to find is you have a virtual machine in which you run all your containers. So you only have containers from one application running on a single virtual machine, which is again in another virtual machine, because then we put it in the cloud. And then we pretend we haven't got anything bare metal underneath it. Yeah, good luck with that pretense. So, are we happy so far? We're all good. So, next up, what is Docker? Any definitions? Anyone want to shout out? No? A person employed in a port to load and unload that ship. I don't want you to go away from here thinking Docker is about containers. Docker is not. Containers are a thing that exists by themselves. Docker is an engine for it. It's a way of loading and unloading that container. It's a way of building that container. It's a way of interacting with it. And there's stuff like the Open Container Initiative that means that this is very much changing. So for anyone who's not heard of the Open Container Initiative, it means that you've got people like Microsoft. I don't think VMware signed up to it, but Docker, the Rocket bunch, they all signed up to a single standard. And this is pretty amazing, actually. So it doesn't matter where you build your container, you should be able to run it in any of the other systems. So the Open Container Initiative is definitely worth taking a look at. They've been going now, I think, for 1.5 years, so it's kind of starting to get some traction, and it's really cool. But, you know, you could also have Docker's own version of it. Containers wrap up a piece of software in a complete file system. Yada, yada. It's a box. Docker is your engine that interacts with your box. But the idea is we're trying to get that kind of, I don't want to use the word stable and secure, but you get that guaranteed way of deploying something. If you build it, it should build the same way every single time. You should get away from the, it works on my machine, because that is the most frustrating thing. So, let's start playing. On board the slides. So, the best thing with Docker is you can run a container for just about anything. And it's as easy as going, well, I'm going to go to my engine, Docker. I'm going to tell it I want to run something. And then you tell it what kind of container you want to run it in. And there are the 2 terms now. We've got an image and we've got a container. An image is your set of files. It's a dead thing that is waiting. A container takes those files and brings it to life. So it's like saying, well, all of my code, before I've run the executable, that's my image. My container is when I've hit go. So I'm going to say Docker run in, we'll say Ubuntu. And then we can say whatever we want it to run. So we can say, okay, hello world. And it'll go off. I've already got the Ubuntu container. Let's make this a bit more interesting. We'll remove Ubuntu. Oh, I don't care how much you think you can keep it. You cannot. Right, so Docker run in Ubuntu. Echo, hello. There we go. So first time, if you don't have a local copy, it goes off to what's known as the DockerHub, and it grabs a copy for you. You can see the layered file system here. So, wow, this is a slow network. Let's not do this a second time. So it's going to go off. It'll get everything for it. And whilst it can theoretically get all of the different layers as in parallel, it has to set up the links between it. So it's a lot like thinking about something like Git, where you go, okay, so I've got this one, and I'll look for my file in this level, and if I can't find it, I'll go back a level. If I can't find it, I'll go back a level. So there we go. I created a container. It said hello. Second time I do it, I've already got all that local stuff, so it's nice and quick now. So we can have a look at all of these bits. You can see what images you've got. I'm going to very carefully grep for Ubuntu now, because I think I might have hundreds. There we go. So our Ubuntu container, this is the first one we ran. 118 megabytes for an operating system. So that's all right. I mean, there are now native Windows containers as well. So Docker runs natively on Linux. It uses the Linux namespace. They're fixing that. That's what this Open Container Initiative is all about. Native Windows containers, the first iteration of them that came out, they were using Windows Server Core, which is brilliant and tiny and fantastic. Their first container was about 3.7 gigabytes. So they're getting there. They're slowly getting there. But you can do this with Windows stuff. It's not just going to be a Linux idea. You can do it on a Mac as well. It's just got a hidden virtual machine that no one ever really talks about anymore. So we've got our lovely Ubuntu thing. And you can see I've got several of them. And you can tag them with different bits. So this Ubuntu latest, because I didn't tell it which version to go get, it went and got whatever it thought the latest was. If I want to be more specific, I say Docker run in Ubuntu. I want 1404 because I like trusty. I could trust in trusty. And you could do the same thing. Echo, hello, world. Oh, I already had it. Excellent. Problem was solved. So you might be starting to think, hang on a minute, what's that latest tag? I'll come on to that rant later. So you can start these containers. You can see a list of all the images you've got. I mean, I've got a few. Got to say, I cleared out most of the work-related stuff, so this is just fun stuff now. But yeah, we've got a few different ones in there. Ooh, that resolution doesn't look good, does it? You can see what running containers you've got, and this is where we get onto a very important difference between a virtual machine and a container. A virtual machine, you press the on button, it stays on. The reason an operating system stays on is it's waiting for input. It's waiting for you to do something. A container, if there is no foreground running process, it just stops again. So if I do docker ps -a, show me everything. I've got loads of these things. So there's my Ubuntu 14.4. It gives it a container ID, very horrible thing. It also gives it a lovely name. This was Elegant McNulty. Best name. We've got Clever Easily, Frosty Minsky. So I usually run a competition. I don't have a prize today, but I'll get you a prize for tomorrow. First person who can tell me how it works out what to name those containers. Because it's got a whole bunch of random ones. And tell me the combination that it will never come up with. It's your competition for tomorrow. So we've got all these different containers. So there's a container for just about anything out there. Shout a technology at me. I'll see if there's a container.
Node.
Node. Docker search. Node. So I'm pretty certain there's quite a lot of these. So we've got two different kinds of images you can have. Ooh. Scroll down a little bit. There we go. We've got this one that's just Node by itself. This is an official container. This is guaranteed to be safe by both Docker and the Node people who built it. This is the one that you should use when you're trying to do anything in deployment. Let's see what else we got. Who thinks we should trust Cuss PVZ's version of Node? I mean, that sounds really good, doesn't it? There are quite a few in here. Dom and Tom, they sound like stand-up chaps. We'll just trust them. We'll chuck that in production. No? So be careful about where these images come from. You can trust the Node one will probably do what it says. I'm only going to say probably, because I've got quite a security background and I don't really trust them. You can roll your own base containers, so it's safer to do that. Just takes a lot of effort, and then you end up rolling everything your own. Yeah. But yeah, you might not want to trust Dom and Tom's one. I mean, my favourite for this is if I search Skynet. Anyone played with Skynet before? I mean, there's a few in here. Turns out Skynet's quite popular these days. So Cyberdyne Skynet. Doesn't that seem good? Nice and safe. So Docker run Cyberdyne's Skynet. There we go. Should go off. Should get it. And the only reason I know this is safe is I actually went and read their source code. But, isn't that pretty? It's all very good. Pre-boot routines, excellent. Requires a mesh. Not sure what that really means in terms of it. Regression nodes, there we go. Got some good old machine learning. Who doesn't love this? Accessing a core. You better not be accessing my machine. Okay, booting. Fine. Everything is good. So this goes on. Skynet Online. Brilliant. Who didn't need Skynet, right? No, stop that. Maybe it's okay. Existential value hierarchy, where do you think we are? Questioning human worth? Yeah. This could go badly. Uh-oh. So there really is a container for just about anything. I mean, that's just a toy. It basically plays with the message of the day. But you can always go find them. Ooh, if I go DockerHub. Well, very important Googling. DockerHub. So we can see what was going on with that one. Because it's an automated container, you can actually have push notifications going from your Git servers, whatever, to the DockerHub, and it will build your container for you. It won't let you search, but it will build your container. There we go, automated build. So if you want to trust something that a person has done, like say Cyberdyne, look for this automated build, because then you at least get, this is the Docker file that was used to create it. I mean, not brilliant, but I can then go have a look at the GitHub bit that's linked to it, so I can have a look and check that is safe. So let's have a play with something else. Docker run. I introduce you to a few more bits. So I've got -p. So by default, a shipping container doesn't have windows. And I mean windows in the sense you see through, not the operating system. You can't sort of peek inside it. So -p allows you to map ports. So I can say from 8080 on the outside, that's on my host, to 8080 inside my container, and I can run good old Jenkins. Who doesn't love Jenkins, right? I could go do that. And it goes, all right, brilliant, I'm going to start building this up. And it's spitting all of this out into the command line. This doesn't seem ideal, because now I need to open a new terminal. That's a bit rubbish. Let's kill that. So instead of that, we'll give it another one. So -d. So I'm going to now detach from this and just tell it, go run in the background. It goes, okay. So I've created this wonderful little container. It says it's Jenkins. It's running on port 8080. Let's see. Anyone used Jenkins? Installed it? It's really difficult to install, isn't it? I mean, it takes a long time to get this up and running. Oh, no, wait, there it is. And maybe you've got more than one team. So this has the wonderful name, Musing Samet. That's not a brilliant name. Not if I want to know what's going on. So I can give this the name tag, and I can say this is going to be for team 2. Oh, and I'll have, why have I failed? Can't bind more than one thing on the host, so I'll have 8081. Right. This leads me on to a beautiful thing, where I tried starting this, it didn't work, but the container's still here. This is still hanging around, so I can't start another one with the name team 2. I can start another one with the name, say, team 3. That'll be fine. I can start one with the name team 4, as long as I remember to change my port. But you can't cross the names on it. So that team 2 Docker container will always be there until the point where you start clearing it out. And this is a brilliant way to clog up your hard drive. People forget this stuff. So if I have a look at my running things now, I've got my 3 beautiful containers, 3 little Jenkins machines. I worked with one company once that was paying out, I think, about £15,000 for a Jenkins machine to be set up. They didn't like when I showed them this. Well, they did. And then they got very, very angry. So you can do some interesting bits with this. But I was on about this. Var log docker. All the stuff it leaves behind. Var lib docker. I did promise that, there'll be live making mistakes. So everything Docker does, it drops into this var lib docker directory. And I'm going to do the best command ever. Please never type this unless you are willing to sacrifice your computer. I mean, I've got a guy who can fix it. It's brilliant. He'll be really angry at me for doing this, but hey. So this var lib docker directory has everything in there. So if I look in containers, I've got a whole bunch of things. These are the different containers I've got. This includes all of my stopped containers. Volumes are where it's storing all of the hard drives. And I mean, I've only got a few of those. That doesn't seem like a lot of volumes, right? Only a tiny amount. Yeah. The best one, though, I think it's images. So ls image. So layer database. And there we go. So you can really start filling up your hard drive with a lot of this stuff. Because your container stops, it doesn't go away. If anyone has decided when they were building that container that they wanted to keep one of these directories, so a volume in there as a special thing, it doesn't go away. It doesn't even go away when you remove the container, because I'll do that in a minute. Our volumes directory is still going to be full of crap. So this is deliberate, though. The idea with containers is because they're ephemeral things, they're processing units, you keep all of your data somewhere else. So there's a guy doing a workshop on Thursday all about scaling databases, because my approach is I chuck everything at a database and he deals with it. You don't keep any data that you want to keep safe inside your container. Now, volumes are a way of kind of doing that, because what it does is it takes this directory inside your container, say your varlib MySQL directory, that bit where all the databases were, and it puts it on the host. So rather than dealing with horrible replication in databases and all of that craziness, you just go, well, I'll have 5 containers with MySQL databases. They're all going to point at that one directory for their data. One gets read-write, and the rest get read-only access. Let's talk about this whole replication thing again. We're not going to need that anymore. So, Docker, yes. So I've got these 3 beautiful containers up and running. When they're currently existing, there are 3 different ways of interacting with them. Now, I usually call them the good, the bad, and the ugly. So we've got our lovely, lovely safe way of dealing with them. So if I say Docker logs, there's no S, Docker log. This will go to that standard out stream of rubbish that was happening. So all of that stuff that was coming out, and I can give it, oh, what are you doing? Team 4. And it will go through, oh, maybe it does have an S now. There we go. So it gives me all of that logging information. And you can send this out to wherever you want, but I can have a look at these logs. I can even say something like -f, bit like tail -f, follow along this thing, and just keep updating as time goes on. So you can have a look at what's going on the foreground of your container. This one's the good one. This one's safe. Reading a thing never damages a thing, unless you're doing quantum computing. We are not doing quantum containers. No. That can be next year. I'll do quantum containers next year. Right, so that's still okay. The second one we can do, so this is the bad, we can attach ourselves to a container. So I can go to Team 4's container, I can attach myself, and this drops you into the foreground running process. And it may look like, I've done nothing, and you're thinking, well, what's going on? And I'll press Control-C, and I have now just killed that foreground running process. This has now brought down my container. So attach is really quite risky. You probably don't ever want to attach to a running container. Oh no, that one's the ugly. The bad is new way. So third way is if I've got my 3 containers, Docker exec. Now, the principle with Docker containers is you should only really have one thing running in a container. You want to do PHP and MySQL and Node, they're all separate things. You want to Redis database, it's another thing. You want to put a Redis database in a Docker container and then keep it alive forever? Good luck. Don't do that. At least keep your data outside, for love of anything. So Docker exec lets me start up a second thread inside a container. So I can say Docker exec, I've got another couple of flags now, -int. So this will tell it, make it interactive, give me a terminal. And I have to say where I want it to be, so team 3. And then you can give it a process, so I'll just say it's bash. And I can jump inside it. So you see I'm now Jenkins at 0042, whatever. That's the same as this container ID. So I can have a look around, I could be, oh, hey, what's over here? What's running? So I've got 4 lovely containers, and so this one, it seems safe, because I can exit this, and I'm just exiting that process, and everything's fine. So what happens if I go in here and say, so doc, ps -aux, let's do kill -9 on, I don't know, that Java thing's really big, we don't want that, so ID number 7. So you can actually bring down your running process. By bringing down Java, I bring down the entirety of Jenkins, so I've killed my container. I'm now back at root at whatever. So you've got these ways of interacting with them. You've got your very, very safe, I'm only reading. You've got your very, very bad attaching to that foreground. You've got your kind of probably safe, maybe in the middle. Who knows? Depends on what you do with it. I mean, I'm not a very responsible person. So, still got one running. From the outside, we have different ways of interacting with it. So it depends on how nice you're feeling to your little container. You can say Docker stop, and it sends it a lovely message. It says, please, could you stop this container? It finishes writing files. It shuts itself down gracefully. Or, you know, Docker kill. And we'll give it, oh, I'm using Samat. And it just goes dead. Straight away, nothing going on. It just absolutely kills that thing straight away. Still happy? Still full of joy? I'm not happy. I've got all these things. Look at this. This is clogging up my hard drive. This is terrible. So just because they've exited doesn't mean that they've gone away. You can start some containers. So Jenkins, because I've got a foreground running process, I didn't need to say echo hello world. It knew, based on when we built it, that it was going to bring up a Jenkins machine. So it's just running the war file as the foreground running process. So if I say start, it'll just go, oh, I'll start that foreground process. If I try telling the echo hello thing to come up, it'll go, well, I'm going to come up, my process is finished, I'm going to go down. And you can do this again and again, it's just going to keep going down. So sometimes you can restart them, which is why it doesn't automatically get rid of them. You might want to keep them around. But if you're feeling particularly mean, we've got what is affectionately known as the Docker Nuke command. So it's not an official Docker command, but we could do Docker remove. -f, I'm going to force it to remove, so if it's alive, I'm going to kill it, and then I'm going to remove it. And into that, we're just going to put in, docker ps -a -q. So list me all of my containers. Do it quietly, because what this does is it passes along word by word into the kill thing. And this should go through and destroy my containers one by one. That's lovely and fast on this, because I'm running it natively with Ubuntu. If you're on a Mac or Windows, you might see it take a little while to get through them all. But now, -a, beautiful. Isn't that lovely and clear? If I look in my containers directory, nice and empty. If I look in my volumes directory, though, well, that's a bit of a problem. So the way most people tend to have it is you have a cron script, it just goes through and kills everything in there. But you might want to keep something in there. So if I pick one of these at random, let's go have a look at see what's in this one. CD that. Volumes that. There we go. I've got a data thing. And we've got absolutely nothing in it. So whoever declared this volume clearly didn't want anything saving. So I'll do a bit with volumes, why not? So now, you see, when I said I'm going off on a tangent, this is a tangent. I don't have time for volumes, but volumes are important. So what we can say is something like docker run. I'll give it my int flag. I want to make an interactive terminal, and I want to have a volume. So you give it a -v. And you can map from anywhere on your host to anywhere inside your container. So before I do this, let's call it Docker DITA. So Docker run -it, give it a volume from Docker data on my host to inside container. So this will map between the two. And then, what's my last two bits? Image, thing I want to run. So now I am root at B02. I'm inside my container. If I have a look, I should have a beautiful directory. So this is what that volume stuff's doing. So if I say echo message to inside container, hello, and then we go have a look at it from the outside world. So I'm going to leave this container running. Docker data. There you go, I've got a hello message. So you can actually spit information out onto the host. And it can go the other way as well. So I can send that, most important command in the world. Run that as soon, no, okay. Just trying to be mean now. Goodbye, over to other. There you go. So we'll go inside the container and have a look at that. So it goes both ways. So what you can do, a lot of these places where it's stuff like, we've got our built container, but we've got our parameters in a separate file, you could say, have that separate file on a mapped volume, and if you want to turn a feature flag on or off, you just change that file, the containers have already got access to it, next time they go have a look at it, they go, oh yeah, right, I should stop people from getting at this Japanese translation thing. I just learnt it took down Twitter, it's kind of amusing me. But yeah, so we can mess around with these volumes, and that's how you can store your data. And then you can have something on the host that deals with it, or you can map into an EC2, not EC2, S3 drive, whatever you want. There are different ways of doing it. So we're happy so far? Full of joy? Let's have a look at the slides. I should pay lip service to them, I guess. So running containers. I'll drop a copy into Twitter at some point, so you can all have a look at these. Choose your own container. We're okay with searching for things. Goes off to DockerHub, comes back. Interacting with containers, right, so 3 methods. What are my 3 different methods? Good, bad, and ugly. Attach. Was that a good one? That was the worst one, yep. What else did I have? Logs? Yep. Logs good or bad? What was my final one? Exec. Yeah, good or bad? A little bit, maybe, so yeah. Logs, really safe. Exec, kinda safe. Attach, nope, 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 nope. So one of the things that people sometimes do for this stuff is if they don't have a foreground running process, they'll do something like Docker run, give me an interactive terminal, now detach from the interactive terminal, a bunty bash. And it goes, okay, bring your container up, Docker PS, still there, look. There's my Ubuntu bash. It's brilliant. The other one's over here. I'll exit that so you can see it properly. There you go. So we've managed to bring up a container. So now if I do docker attach to Cocky Bassi, that is a good name. So I'm now on that bash session inside that container and exit. Bye-bye container. So they can be quite... Attach, I very rarely can think of a reason to actually use. Yeah, just don't do it. Just don't do it. Stopping and killing, happy with that. That was nice and easy. So what's left behind? This is a good way to kill off your infrastructure. Basically, if you leave these volumes lying around, because when you build a container, you can say this is an important volume. The Jenkins one has the Jenkins home as the volume it creates, which means it spits it out into that directory on your host. And if you're not aware, you're just going to fill up everything. So be very careful about this. So, step 2. I'm running out of time already, aren't I? Building containers. We'll do this one quickly. So there are 2 ways of building containers. One of them is terrible. One of them is basically like scripting. So I'm not going to talk about the terrible one. I'm just going to talk about this one. And you get basically this idea of do stuff one by one. So you say from some kind of base image. So in this case, I'm saying Ubuntu. Go get me the tag 1404. I want specifically that version. Run a bunch of commands inside it. And each of these, what it does is it brings up a container, runs that command, and then stops the container. So here we've got things like, well, change my working directory. So work dir is a special case where it will persist a change from one step to the other. Because otherwise you'd have, say, run cd whatever. It'll go bring up a container, I'll cd into that directory, I'll stop my container. Then the next time I go in, I'm back as the root user on the root directory. So you have to have special things that will let you persist a change from one bit to the next. So you can say things like work dir user is the same. I switch a user, that's the process ended. I'll stop that. Don't need that anymore. You can say things like expose AT80. So this is telling someone who wants to run it later, by the way, this port might be quite useful. You might want to expose this to the outside world. This doesn't guarantee that anything outside of that host can reach that. The host always has a chance because it can just go through the subnet it's creating inside it. So I've got a simple example for one of those, I think. Docker file. There we go. It's a very, very complicated Docker file. I'm hoping you can work this one out. So what it should do, update, install a thing, then stop. So building these things, Git, conferences, where am I? I'm at the Continuous Lifecycle Conference. All right. So Docker build. And this is one of the gotcha moments. So we'll give it a tag, we'll give it a name, we'll call this one Hello World. And then we'll hit enter, and it goes, I require an argument. And you think, well, I gave you a tag. What do you want? Always remember to tell it where you're building this. It needs to know where to find that Docker file. So we're going to put a dot on the end that says basically build that here. And there's a secret to Docker containers. This was really fast because I built it before. You see this? Using cache. You can optimize your build process for your Docker containers. So stuff that stays the same, you can put at the top of the file. And once it's done that once, it doesn't need to do it again. It just goes, I've got a copy of that. I'll just go use the copy I've got. It doesn't duplicate work. And you put the stuff that's likely to change, like, say, copying in your final application right at the end, because that's the only step you want to repeat. And that's the thing you want to have different each time. So you can optimize these a little bit. But yeah, so I've got a few examples. That was the one on the slide. That's a bit boring. There you go. Here's one I was working on yesterday, trying to get Ruby to work. So you can say all sorts of things, so like run apt-get update, install a bunch of stuff. There is a theoretical limit to the number of layers. Well, it's not theoretical. There is a limit to the number of layers you can have. It used to be 42 because we're a bunch of geeks. It's now 128, I believe. So when I finish this, I might actually want to condense these into the same line. It's not very good. But you can do stuff like cloning stuff into your container. You can do stuff like trying to install bundle. You can do things like swearing at RBN for breaking your setup once again. Anyone do Ruby? Yeah, I might come ask you later how I broke my laptop because it's not working anymore. This is one of my attempts to fix it, is put it all in a container. So you've got quite a lot of these. Now what this doesn't let you do is pass in variables. Docker files are very much one-to-one mappings. You give it this, and you'll get out a container that has run that stuff one by one. Ideally, these are idempotent functions. But, well, apt-get update. Is that the same today as it was yesterday, or the day before, or the day before that? So this one's a bit of a tricky one. So you tend to have it at the top of a file, and then you often have it right at the end of a file as well, just to make sure, you know, go get me those lists so I can do something with this. But there are other systems out there. So Rocker is not quite the same as Docker. It's an independent project. But if you want to do, say, we've got one project where I'm building a load of base images. So I've got Java, and I want to build it with 3 different versions of the JVM. I want to build it with 2 different versions of McIvor, 2 different versions of New Relic being installed. Then we've got whatever the departments wanted to add on top of that. So I've got a bash script that will run through something like this and go, well, I'm going to pass in a tag each time, so this time 1404, and it replaces it in there. So it's just very simple kind of Go templating that lets you do things. And you've also got things like tag. So I know that we now have multi-stage builds in Docker, so that's slightly less impressive. But you can actually tell this Rocker file what to tag the final image as. And then you just run it with that Rocker build, pass it the information, and it'll go off and it'll do it, hopefully, for me. Let's try it. It'll ignore me. What's your problem? Let's be me again. Git conferences, continuous lifecycle. So rocker build, give it the variable of tag equals 14.04, the variable of image was cat. There, that's better. It doesn't like running as root. So it's the same kind of idea, but it gives you a bit more flexibility in some of these bits. Now you might agree with this or you might not. You might like your one-to-one mapping. I know a lot of places we use this to generate our base images, and then when we hit the project level, so all the developers coming in just go, well, we're going to take that and we're just going to do a normal Docker file release after that point. But this gives you some flexibility to be able to say, I want to build all of the different versions of Java we've got and shove our application in and see which one it breaks. So you can get a wide array of different bits. But that's going to take a while. Boring. All right, so building. Are we happy with building? You want to see me run a thing I've built? It's basically the same thing. It goes into that Docker images list. So Docker images. There we go. So I should have something up here. Hello world. There we go. Built that 4 minutes ago. So this was just a container with Git inside it, so I could drop inside and go, hello. Let's have a look and see if Git exists. Also get image IDs. So, yeah, that's about it. Trouble with tagging. So yeah, we have these tags. So you can build things with specific tags. So we've got one. If you don't give it a tag, it goes off to latest. Do not trust Docker tags. Please do not trust. In fact, I've got a really big slide about this. Do not trust Docker tags. What do you think the word latest means? Nope. Any other versions of latest? Perfect. Or possibly the one that they forgot that they weren't labeling as something else. Latest is literally just a word. It is not the most secure, it's not the most up-to-date, it's not the most anything. It is literally, when this was built, we didn't give it a tag. And the worst point you get with this is where you say, well, from Ubuntu, install all of this stuff and run. And you know what? There was a wonderful day where my build worked. It was installing on trust day. The latest tag switched overnight from 14.04 to 16.04, and you know what? Java is not the same on those two. You cannot just install the same packages. And it broke everything. And this was my terrible lesson in don't trust Docker tags. And I mean, it gets even better than this. So 14.04 today is not the same as 14.04 yesterday, and is not the same as 14.04 2 weeks ago. You can push a completely different container, completely different image, to the exact same container ID. So you don't want to be trusting these things. They're a bit terrible, really. So images I've got, Docker images. Yeah. So I've got things like 6.9.1 Alpine. That is probably more trustworthy, but if they patch it and push a new version of that, I'm not entirely sure what I'm going to get. On the other hand, we've got these IDs. These are hash codes now. They didn't used to be based on the contents of your container, but they are now. So that you can say, if I do docker pull CentOS, we'll just go get latest. Hopefully this will be nice and quick, because it gives you the SHA code at the end. So where I've got that from Ubuntu 14.04, stop being slow, very slow. You can say something like, actually, from Ubuntu, SHA at, very, very valid SHA. This will always get you the exact same container back. This is a thing you can guarantee because this is based on the contents. So just be careful if you're ever doing tagging. I mean, at First Utility, we do not use the latest tag. The latest tag is not something that is allowed to even hit Artifactory. We just have it reject, because we don't want people relying on the fact that will be the same today as it is yesterday. And it can't be. We in fact have Artifactory rejecting anyone trying to push to a tag that already exists because, well, why would you do that? You've got a new version of your application, give me a new tag. Preferably with the version number in. Don't just say, oh, this is just Project X, it's fine. No, I want a version number in there, because then I know that when something breaks, we're rolling back to the version that was working yesterday, and you've got a definite build thing. But Docker by default will just let you override this stuff. You know, you don't care about that. Right, side rant over. So, you think I'd stop ranting, but no, security. So this is just a brief kind of wander through, mostly questions for you guys to think about for later. So, step 1, who built the image? Where did your image come from? Do you really trust that guy? I think it was CPU guy 83. I mean, I trust him because I know exactly who it is. It's a guy who works for Nagios, for the Nagios container. But you probably shouldn't trust a random guy. What was in the Docker file? You can often find links on the DockerHub to the Docker file they say built that container. Unless it is an automated build, it's not necessarily true. Still a problem. What base image was used? If you try and search through that Jenkins thing, you can say, well, from something at the top of the Jenkins Docker file, well, that one leads to this one, and this one leads to this one, and this one leads to this one, and you end up going back about 8 different steps. It doesn't have a visualize anymore. It makes me really sad. And even if you know what base image was used, what was actually in there? I mean, there's a beautiful version of cat bunty. Very, very safe, very secure. I absolutely promise that I did not put a backdoor in it. You should use that for all of your stuff. So you've got a lot of this thing. How do you know what was there? How do you even know you got the right one? Hopefully, my tagging rant will have answered this. Use that hash code. My favourite one. Which user are you running as? It runs as root automatically inside a container. And you should always run Apache as root, right? And Jenkins as root. And whatever application you've got as root. Let's run everything as root. No? Yeah, okay. So testing, I'm getting the feeling it's almost lunch. So testing containers. Basically, there are ways of testing it. This is basically server spec. This will test your Docker file to start with. You've also got other things like, say, GOS. So based on a YAML file, this will spin up your container and then test against the actual container that has been created. So it's always worth having a look at these. So you can see, well, it says the right thing, but did it do it? And I can show you this working later. So, summary time. Right, what's Docker? Go on, you tell me. What is Docker? Engine, yeah? That's good. It's a thing. Does containers. All right. Loads and loads of containers. Loads of... True, true. All right. Are tags safe? Nope. Good. Where do your containers come from? Just think about this. Always think about this stuff. Because I know open source is cool, and I know we shouldn't just keep building our own stuff again and again. But please have someone who knows what they're doing. Look at it. And trust me, you guys will know what you're doing. Right, and very important, do you want lunch? I'm not sure. So that's kind of the end of my talk. Overran a little bit, better than last time. I always figure you're bored of listening to me by this point, so here's a picture of rabbits. These are my 2 rabbits. So any questions, comments? Things you want to talk about? Want to go have lunch? Was it useful? Yes. Excellent. I'm glad. Right, go forth. You are free.